Which of these is brightest? The top one, right? Well, that's because it is. It's a mercury halide lamp, and they produce a lot of light. But they're pretty bulky, they get hot, they take a while to turn on and off, but perhaps most importantly, they contain toxic mercury. But it's bright, so who cares? Well, actually, because it appears so bright, that's a telltale sign of a poor device. These devices are made to emit in the ultraviolet spectrum for applications such as disinfection and water purification. The human eye can only see the visible. So all of this light that makes it appear so bright is actually wasted energy. You wouldn't know if a perfect DUV device was on or off. And this is where LEDs have a distinct advantage. They can be made spectrally pure, meaning they emitted a single wavelength without any wasted emission. And by using this, they also don't get as hot. They can be turned on and off very quickly. They can be made to cover a large area, but they can also be made very small to be portable and fit inside things such as straws or catheters. But they have a drawback, and that's the price. They're expensive because of the slow manufacturing techniques that can typically only produce a few square inches at a time and require expensive crystalline substrates. I use a technique called molecular beam epitaxy to grow LEDs. It's not grow like plants, but more like stacking atoms like Legos. I have a chamber that's under extremely high vacuum to keep out impurities, and then I spray paint atoms at a surface. But I do this with a twist. I don't make a thin film like spray paint. I grow a carpet of wires, nanowires, where the width is on the order of 1,000th the width of a human hair. And because these wires aren't touching each other, it allows me to do a few cool things. First off, I can grow them on basically whatever I want. If I can grow them on anything, what do I choose? Metals. Metals are inexpensive. Metals are strong. Metals can be thermally conductive and electrically conductive. Some can reflect light like a mirror. But a cool thing that you can do when you use nanowires and metals in conjunction is you can enable flexible optoelectronics without any added device processing. And this opens the door to high throughput manufacturing techniques such as roll-to-roll fabrication. I've already demonstrated working ultraviolet LEDs on metal foils, and I'm now working on increasing the efficiency in the germicidal regime in order to move towards that large area high throughput manufacturing scheme. Thank you.